The scale of industry investment in and commitment to North Sea oil and gas production is staggering. This platform, indeed any major platform, can readily cost in excess of £1 billion sterling, an investment equivalent to the total research and development budget for Concord. Such a valuable investment clearly needs to be protected from both the harsh working conditions of a traditionally tough industry and the ferocious environment of the North Sea. Obvious. Far less obvious is the challenge which faces architects when seeking to engineer such protection. And this part of the programme is concerned with the nature of that challenge, with the role that design expertise played in solving the problem, and with the overall productivity, efficiency and safety benefits that good design offers. Benefits which the oil and gas industry, not only investing money, but also the lives of those operatives based on a platform at any one time, very definitely needs.
The hallmarks of good design are balancing a number of conflicting interests. The designer has got to balance the requirement of the customer with the requirements of the manufacturer. Safety and protection requirements are interesting because the requirements there come largely from meeting legislation rather than what the manufacturer wants to provide for the customer, because in the main it is prescribed by legislation. There are quite often additional things that the manufacturer wants to provide which are outside the legislation. And this is where the designer's innovation comes in providing exactly what can satisfy the legislation as well as being a good solution for the customer.
The architects seeking to improve the protection of platforms in the North Sea have two basic elements to contend with: the weather and the working practices. The flaring of waste hydrocarbons, a necessary safety practice, could generate intense radiant heat in a major emergency. Temperatures can reach, even at a distance of 200 meters, in excess of 200 degrees centigrade. And in an average year, a North Sea platform could have to contend with 70 days of storms of force 8 and above, gales, freezing temperatures, sea spray, encouraged by average January wind sea of 4 meters, rain and frequent driving snow are basic to North Sea life. The design challenge does not lie in identifying a protective mechanism capable of withstanding the heat from flaring and the wind and the cold of the North Sea. A solid shield would quite obviously fulfill that function. No. The design challenge is that a solid shield, apparently the only device capable of simultaneously contending with both flaring and force 9 gales, can also affect operating conditions and overall safety. The problem is a critical one and must be carefully considered, because while platforms must be protected, operational and safety standards must not in any way be sacrificed. This is a Locker Radiant Heatshield. Its primary function is to protect people, equipment and the platform itself from the intense radiated heat generated by flaring. Made from stainless steel woven wire mesh, the shield allows a reduction in radiated heat of nominally 70% over unshielded situations. A highly significant feature confirmed in test situations by independent third parties, such as the Loss Prevention Council, formerly FERTO, and the Building Research Establishment, which subjected the Locker Heatshields, for example, to 60 kilowatts per square metre. But the really crucial characteristic of this heat shield is the way in which the design solves the apparently contradictory objectives of protecting against radiated heat and protecting against wind and the natural elements, while maintaining good operating conditions. The solution is not in the shape, the frame, however different, or the assembly. No, the key feature is this: the wire mesh. The woven steel wire mesh is very light, immediately removing the first problem associated with solid heat shields: weight. It's therefore easy to install and exerts less stress on the platform structure. It's also see-through, enabling high visibility, which enhances both safety and normal efficient working conditions. And while the Locker Shield's mesh allows for the free movement of air, it's nevertheless solid enough to provide protection from driving wind, rain and snow, thereby achieving the apparently impossible: protection against the wind and rain without restrictions on the free flow of air, which would otherwise contribute to the dangerous build-up of pockets of gas. Finally, construction from grade 316 stainless steel produces a heat shield which is corrosion and maintenance-free and able to withstand cyclic conditions without detriment to its characteristics. The Locker heat shields are available in two forms. The ladder is a double-sided shield consisting of a primary and secondary mesh welded to a pillar structure. The air gap between the two meshes serves to protect operatives from the heat absorbed by the primary mesh. And the Mini, a single-sided shield, for use in areas where either the radiated heat is lower or where personnel require no protection from the heat absorbed by the primary mesh. Being lighter than the ladder, the Mini heat shield is also ideal for use in situations where weight is critical and where personnel are unable to touch the primary mesh. All materials used in the construction of both the Mini and the ladder carry a chemical material analysis, wet stamped, traceable back to cast, while other materials are supported by letters of conformity. Every element in the Locker Radiant Heat Shield is therefore certified and quality is assured. A fact verified by the enthusiasm with which the industry has specified the Locker Radiant Heat Shield. Over nearly a quarter of a century of successful use, over 28,000 square meters of Locker Radiant Heat Shields are now fitted to offshore platforms in the North Sea and elsewhere.
The heat shields are tested for their integrity both mechanically and from a heat radiation protection point of view. The radiation protection given by the shield is nominally a reduction of 75%. Installation of the heat shield the operators find very simple. They're light in weight, simple to install, they're bolted on, they need no special tools. A wrench and a socket type spanner is all they need. The shield itself is passive, one would term passive. It has no moving parts. It requires little or very no maintenance. It has no other services required for it to maintain its integrity: water, pipework, pumps, electricity. Simple installation makes it very cost effective. The integrity of the shield is being proven by the number of operators that are using it in the field.
The Locker Radiant Heat Shields represent a classic example of design at work in the oil industry, and the important role which design can play in improving both safety and operating standards while protecting both capital investments and crew. Setting a design standard which other parts of the industry would do well to strive for, improving safety, enhancing performance, and protecting plant and personnel from the extreme and changeable circumstances in which they're forced to operate. Locker Heat Shields, an example of design for the industry by the industry.